Okay na po, ma'am. You may start. So good afternoon, everyone. We are the Group 2, and we're going to report the Laboratory Activity 6, Avogadro's Constant.
The objectives are the following. First, to understand the concept of Avogadro's constant, then to be able to understand the importance of Avogadro's constant in conversion, and to be able to convert numbers of atoms to number of moles and numbers of atoms to grams.
So the number of units in 1 mole of any substance is called Avogadro's number or Avogadro's constant. And it is equal to 6.0221 times 10 raised to the power of 23 particles per mole. Then Avogadro's number or Avogadro's constant is the number of particles found in 1 mole of a substance. It is the number of atoms and exactly 12 grams of carbon. Then the author of Avogadro's hypothesis in 1811 is Mr. Amedeo Avogadros, and the uses of Avogadro's number is to calculate value of the number of atoms, molecules, etc. in a gram mole of any chemical substances. Next po. So there are two formula of the Avogadro's numbers. The first one is the number of atoms to number of moles. In this formula, we're going to find the moles of an element. So the formula is number of atom times moles of an element over mole of Avogadro's number of an element is equal to moles of an element. Then the second formula is to find the grams of the element. So the formula is number of atom times moles of an element over mole of Avogadro's number of an element times molar mass of an element over moles of an element is equal to grams of an element.
Convert the number of atoms to the number of moles. So we have here 3.50 times 10. 3.50 times 10 power of 17 atoms of astatine. So the formula is number of atoms times moles of an element over mole of Avogadro's number of an element is equal to moles of an element. So i-substitute lang siya. So 3.50 times 10 to the power of 17 atoms of astatine times 1 mole of astatine over 6.022 times 10 to the power of 23 astatine atoms. Tapos cancel lang yung atoms para maiwan yung mole of astatine. So it equals to 5.81 times 10 to the power of negative 7 moles of astatine. Number 2, 4,500 atoms of radium. So same formula lang ang gamitin. 4,500 atoms of radium times 1 mole of radium over 6.022 times 10 to the power of 23 radium atoms equals to 7.47 times 10 to the power of negative 21 mole of radium.
Number 3, 2.75 atoms of silver. 2.75 atoms of silver times 1 mole of silver over 6.0221 times 10 raised to 23 silver equals to 4.57 times 10 raised to negative mole of silver. Next is number 4. 500 atoms of silicon. 500 atoms of silicon times 1 mole of silicon over 6.0221 times 10 raised to 23 silicon equals to 8.30 times 10 raised to negative 22 mole of silicon.
Number 5 is 6.23 atoms of manganese. 6.23 atoms of manganese times 1 mole of manganese divided by 6.022 times 10 to the power of 23 manganese atoms is equals to 1.03 times 10 to the power of negative 23 moles of manganese. Next is to convert the number of atoms to the number in grams. Number 1 is 3.9 times 10 to the power of 15 atoms of barium. So the formula is number of atoms times moles of an element over moles of Avogadro's number of an element times smaller mass of an element over moles of an element is equals to grams of an element. So 3.9, excuse me po, times 10 to the power of 15 atoms of barium times 1 mole of barium over 6.022 times 10 to the power of 23 barium times 1.37.33 grams of barium over 1 mole of barium is equals to 8.89 times 10 to the power of negative 7 grams of barium. Next po.
Next is 8.02 atoms of zirconium. Then given is the 8.02 atoms of zirconium. The formula, same as number 1. Then calculate it. 8.02 atoms of zirconium times 1 mole of zirconium divided by 6.022 times 10 to the power of 23 times 91.22 grams of zirconium over mole, 1 mole. Then the answer is 1.21 times 10 raised to the power of negative 21 grams of zirconium. Then next is number 3. 10.7 atoms of tungsten. And same formula pa rin, then solve. 10.7 atoms of tungsten times 1 mole divided by the mole of Avogadro's number of element, which is 6.022 times 10 to the power of 23 times 183.84 grams divided by 1 mole is equals to 3.27 times 10 to the power of negative 21 grams of tungsten.
Next is 2.56 atoms of mercury. So 2.56 atoms of mercury times 1 mole of mercury divided by 6.022 times 10 to the power of 23 mercury times 200.59 grams of mercury divided by 1 mole of mercury. So equals to 8.53 times 10 to the power of negative 22 grams of mercury. Next. Next is 9.0 atoms of carbon. So 9.0 atoms of carbon
times 1 mole of carbon divided by 6.022 times 10 to the power of 23 carbon times 12.01 grams of carbon divided by 1 mole of carbon equals to 1.79 times 10 to the power of negative 22 grams of carbon.
Is that all?
Yes po, ma'am.
Kindly share the screen again. Sa'yo hindi ko nakita. Nag-report. Kulang yung listahan ko dito. It's not around. Let me see. Oh, okay. Yeah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Ah, okay. 6. Kompleto pa pala kayo lahat. Okay. So this one is for the Avogadro's number. Let me request control over your slide. Ayan. Sige. So, this one again is Avogadro's number. When you say Avogadro's number, it represents the number of particles in 1 mole of a substance. And this is constant. So you just have to memorize this, that 1 mole of our element, for example, is equivalent to 6.0221 times 10 raised to the power of 23. Again, that is constant for the Avogadro's. Now, ayun yung mag-next. Ito pala. Okay, so we are going to follow these two formula. We will be computing for the number of moles if the number of atoms is given. So the number of atoms, i-multiply natin. Remember, sa isang mole ng element, we have 6.0221 times 10 raised to the power of 23 atoms. That's the time we get class the number of moles. But if the number of grams is given, we will be continuing this pattern. After multiplying the number of atoms to the number of atoms per mole, we have to multiply it pa with the atomic weight of the element. Okay? Atomic weight ng ating element. Wait lang, excuse ah. Okay, sorry for the interruption. I'm really not feeling well. Okay. Sige. So the first part is convert the number of atoms to the number of moles. Number 1, this is the number 1, 3.50 times 10 raised to the power of 17 atoms of astatine. So again, the number of atoms will just be multiplied with the Avogadro's number per mole. Pero baliktad siya, the Avogadro's number will be placed sa baba for us to cancel the unit. So this one is correct. 3.50 times 10 raised to the power of 17. Let me check. Times 1 mole divided by 6. Bakit 6.022 ang ginamit? Walang 1, hindi niyo sinama yung 1 na given doon sa introduction. Wala. divided by 6.0221 times 10 raised to the power of 23. But anyway, it's okay. We will still get the same answer. Please do not forget to cancel the units. So this is 5.81 times 10 raised to the power of negative 7 moles of astatine. So this one is correct. Okay? Again, this one is correct. The 3.50 times 10 raised to the power of 17 atoms is equivalent to 5.81 times 10 raised to the power of 7 moles of the same element. Okay? So again, this is not really a very difficult one, but you really just have to be familiar with our conversion factor. Let's see the number 2. The same way of solving. So 4,500 atoms of radium, cancel the atoms, divided by 6.0221 times 10 raised to the power of 23. Okay, this is correct. 7.47 times 10 raised to the power of negative 21 moles. Okay. Next. Okay, so this one naman is 2.75 atoms of silver. So 2.75 divided by 6.0221 times 10 raised to the power of 23 is 4.57 times 10 raised to the power of negative 24. Okay, this one is also correct. Next. Number 4, I think 5 lang ito, no? Ito, 500 atoms of silicon. Konti lang, 500 atoms divided by 6.0221 times 10 raised to the power of 23. 8.30 times 10 raised to the power of negative 22. Okay? This one is also correct. And then lastly, for number 5, we have here 6.23. We will really expect a very small number of moles here since masyadong maliit na din yung 6.23 atoms. We cannot even see one atom. 6.23 divided by 6.0221 times 10 raised to the power of 23. So this is 1.03 times 10 raised to the power of negative 23 moles. Okay, so you got the correct answers for all of the given from number 1 to number 5. Okay, let's continue. Sige na sipon dito karon snipers. Okay. Now, convert the number of atoms to the number in grams. So, you have to multiply this sa atomic weight. Do not forget to use the whole number for the atomic weights. Please do not forget that that has always been my instruction. Even Chem101, I don't really use atomic weights na merong decimal. Lahat yan pinapa-convert ko to the nearest whole number. So yeah, but anyway, let me see. This is 3.9. 3.9 times 10 raised to the power of 15 times 1 mole of barium. And what's the atomic weight of barium? Barium is 137 only. So times 137 divided by sa ilalim 6.0221 times 10 raised to the power of 23 is 8.87. This is 8.87 times 10 raised to the power of negative 7 grams. So again, our pattern here, the number of atoms multiplied sa isang mole ng substance, meron 6.0221 times 10 raised to the power of 23 atoms. And then to get the number of grams, do not forget to multiply it sa atomic weight niya. Atomic weight ng element. So again, for number 1, we have 8.87 times 10 raised to the power of -7. Right? Next. So for number 2, this is 8.02. Konti lang. So ang grams nito, konti lang din. 8.02 times 1 times 4. This is zirconium. Oh, wait. Zirconium is 91. This is 91 times 91 divided by 6.0221 times 10 raised to the power of 23. Yes, this is the correct answer. 1.21 times 10 raised to the power of -1. So this one again is correct. And then let's have number 3. Number 3 is 10.7 atoms times 1. This is tungsten. Tungsten is 89. Yeah, 184. 184. It should be 184 divided by 6.0221 times 10 raised to the power of 23 is 3.26 times 10 raised to the power of -21 grams of tungsten. So, kung ganito lang kakonte yung atoms mo, all the atoms will weigh 3.26 times 10 raised to the power of -21 grams. Masyadong maliit. And then, number 4, we have 2.56 atoms of mercury. This is very small also. So 2.56 and then times 1 times yung mercury, Hg is 201. 201 divided by 6.0221 times 10 raised to the power of 23 is 8.54 times 10 raised to the power of -22 grams of our mercury. Okay? And then lastly, last na ito, 9 atoms of carbon only. So 9 times 1 times 12 divided by 6.0221 times 10 raised to the power of 23 is 1.79. This is correct. 1.79 times 10 raised to the power of -22. Okay? So questions about converting the number of atoms to moles and even to grams. You have questions or clarifications? May gusto kayong i-clarify? Wala naman na? Okay, that's still part of stoichiometry ha, kasi we are determining the number of substance here, specifically the elements. If we know the number of atoms for a certain element, then we can always compute for the number of moles and also the number of, the amount in grams. Okay? So thank you reporters for that. No questions na? Sure na? So I'll be